physics, we are going to be introducing you to some of the lecturers, some are from India, Russia, Nigeria. And then you're also going to learn about what physics, the different branches of physics that you all can enter in, right? So those of you all who kind of get into medicine or engineering or whatever other field, you can see that there are really wonderful options here if you want to choose from, okay?
Environmental technology, major in physics. You can do major in computer physics, chemistry, physics, mathematics, things like that. Then we have a BSc special degree, which is called biomedical BSc. And then we have also minors, 4 minors we offer in material science, environmental science, and then biomedical and electronics studies, which we use in our day-to-day life. That was done, most of them were done by physics people. For example, you have mobile in your hand, so that is LCD, liquid crystal display, so that was discovered by physics people. So that is, material science means you engineer some material, you force some material to take some structure according to what we need.
To introduce you all to someone, and he was actually my supervisor, which is Dr. Nicholas Musika. So he specializes in medical physics.
The treatment in hospitals like CT scanners, ultrasound machines. So this all stuff is described by physicists, by people, or people, either by diagnostic or by treatment, have to have knowledge of physics.
How many applications of renewable energy?
You are choosing and one program and I'm able that you are going to choose particular certain basic principles. Materials here, two similar materials. And when like force on it, it produces an electric charge, right? This is how portable. You'll see them all over the place now, right in front of campus. We have a set there, they charge electric cars. How would you eventually will have them in all of the street lights and that sort of thing, right? And when I bring it up towards the thing, you notice how it's like. You get, see there's no battery, right? We are custom with that. But just by this light, solar energy, lights from the sun will actually cause the charge to produce the electric charge, and that will actually drive your lights in your house solar fans eventually. There's a photovoltaic panel here. When I put the light on it, the car will move. Light around. You know, you use it in warfare as well, right?
So some undergrad courses specifically faculty physics programs and these are some master programs. In our lab, we're using both signal generator as well as multi-type transformer, which is producing the AC current to get from the house. Right, this is just one of the lab. This is one of the experiments that we do. It's a mini sonometer in a tube. A frequency generator, which we feed into a speaker, which is on the side here. We also have a piston, which seals one end of the tube, and we also have a movable mic. So with this now, depending on the frequency generated, you can actually determine the nodes and antinodes along the tube, similar to the waves on a string experiment that we all would have done last semester. Bench with the mirrors, the object, and the light source, the lens. Now, does anybody know why determining the curvature of a lens is important? How the lens focus is very valuable in optics, because right now in astronomy we don't use refractor telescopes anymore, which is lens focusing on lens. We have reflector telescopes where light enters the telescope, it's refracted onto the lens, so a viewing piece. The light that we see And when the shift up, you should determine not only in which direction that the plant is turning, but also the speed at which it is turning. And that is one of the things that they use to determine if
So, you all are aware that when you go to the hospital, usually if you're having cardiac issues of some sort, they perform an ECG. Now, there are many different types of ECGs, and those are usually based on the number of leads. So this, what we have here, is known as the 12-lead system. Audiometer. And based on this, we transmit signals to the patient, and using the indicators, and these will say whether or not they can hear it. From those, it will generate a waveform, and those will allow us to see whether the patient has normal or abnormal hearing.
we have what is called the feedback lab. It simulates your nervous control system and your muscles. Inside of this lab, it will show you how, well, this is one of the inputs that we have. It shows you the onset of Parkinson's and Alzheimer's.
This is known as EOG or electroculography, and this tests the electrical signals in the eye that is generated when the eye moves with a different type. Slow tracking, which is slow eye movement, fast tracking, fast eye movement. And of course, we use a combination used to test dark and light adaptation. So you know when you go into a room, a dark room, you're not able to see immediately, but after some time you can see. This tests how fast you're able to do that and how good you're able to do that.
It will actually measure the depth time. So let's assume you have a full tank of water, all the lights are illuminated, right? As you start to use water, the water level goes down, and then one light goes off, so you know you're down to 2/3 of a tank. Goes down a little more, you're down to 1/3 of a tank, and then you should have put it back in tank. Right? So it's just a simple thing to show you.
And this now, you can measure the proper height of a person. This one here, somebody would actually sit down on the table and you'll be able to get their, what's the head ratio, right? Okay.
Physics!
It's primarily a PG lab. We have about 20 to 30 PCs in there.
Agree? When we are working with physics, when we are talking physics, some electronics is there, some mathematics is there, right? So when we talk about applications, so there are a number of applications, physics and electronics, right? I think I will be a small portion. So this is the application of a embedded system. No? Digital watch. Yeah, digital watch. So this is the very good application of electronics, right? So when this digital watch is the small one, you can measure the middle of the signal, heart rate, sunlight, it set up, and you heard about chat, etc. Okay, so we are going to launch that program soon. We will see what are the basics of AI, on what basis the chat GPT or the search engine or other engine for generating AI, how that can work. So we're going to teach that in the embedded system. So embedded system is basically like the microprocessor your cell phone. They are basically embedded system. So we also focus on that embedded system. Typical like we are not able to do that system, okay, so we can still go that, and then after doing SPSC, we will be basically properly skilled to get along with this kind of communication industry. Then other, for example, we have other standard institutes where they are contributing to that. And microphysics is there, so that we is also working on medical devices. In designing medical devices for different kinds. You can see now we have particles of technical, we have AI detect. You will see over there. Just browse our website.
So you can literally grind down or smoothen or polish different metals using this machine, right? Doing this, we can determine the rate at which muons hit the planet and how many there are. We have a material which we cool with liquid nitrogen down to 0 degrees Kelvin, and using different voltage and current meters, we determine the magnetic field given off by superconductors to develop a lot of different applications. Some of these applications are monitoring systems and alarms.
You can see the temperature will start to drop. At a certain point, the buzzer will start to go off.
Photons, and it's being sent through two slits, and then you will detect the apparatus with that box down here. It's hooked up to a computer, and you'll actually see how the photon is. Come straight across. It's fed into the room in the back where it has a controller where it actually converts the current. The silver part on top are the tanks. Actually, it's a solar water heater, and they can be recorded with the down here, we have a weather monitoring station. There's rainfall, sunlight, speed with direction, rainfall, and light intensity.
And then you all will see that you will find that there are telescopes and stuff inside it. They are very powerful, and because of how expensive they are, we don't really have much. That's why we don't come out and then you want to interfere with them, right? Because you have to be trained and you have to go through a procedure before you actually get into them, right? So if you all decide to want to learn about astronomy, they also have a club. This is run by Professor Sharon Hack.
A loan system, which means that we have battery packs, battery couplers, and then the batteries DC power 12 volts, and inverter, which gives you the house current. We have a lab downstairs, this computer lab, 10 computers are powered by these panels, all the same, right? That's what I mentioned to you downstairs. We don't have a facility powered by its own, but it's powering the whole building.